Okay guys, so here we are once again with video number 2 of 3 of these series of videos where I explain what my project was about. This is the circuit that is behind the little electronic board that controls the whole thing and that I showed you on video number 1, and in this video we are going to see how this behaves. Before we do so, I just wanted to do 3 very brief considerations that are going to make you understand a bit more of what's going on. The very first one is this one. As I already mentioned, this bar is controlling 2 switches at the same time. This one is the main one, while this Y is the secondary one. Now in this circuit here, for the moment I just draw the main one, which is this one here, and I'm gonna draw the secondary one only at some point later on, and the reason for that is that the secondary one has been introduced in order to resolve a problem, and I'm just gonna draw it only once I'm gonna go to the point where I'm gonna explain what this problem is about, so please bear with me for a minute about it. Second one is about these couple of lines here that you see. What they do is that they represent the conductive rails that you see here. Okay, yeah, it really looks like a donut. It's just I'm very bad at drawing. These 2 gaps here, they just represent the cuts that I showed you in the first video at the very end of it. Are the 2 cuts that isolate this part of the track. Okay. Third and last consideration is something very important, and it's about the fact, and I already showed you that on the first video, is that the circuit must work correctly independently from the transformer's polarity. This is a necessary condition in order for the circuit to work as if we were using the original accessory set. Okay, so now that's it. These are the considerations. Just very briefly, I'm gonna tell you what these symbols mean, and then we're gonna move to the analysis of the circuit. Okay, this 12 volt here, these represent the power supply, the 12 volt transformer, and this is the main switch, as I already said. These DBs here mean diode bridges. There are 2 of them. Each one is connected to each of the LEDs. These represent the green LED, and these represent the red LED, and each one of the LEDs have their own resistor that you see here, and the values I calculated for the resistor are 4.6 kilo ohm for the red resistor, or the resistor associated to the red LED, and 3.3 kilo ohm for the resistor associated to the green LED. Okay, so there we go. This is it. So let's move on and let's see how this circuit behaves. Okay, so as first case, I would like to consider the scenario where the red LED is on and there's no power supplied to this section of the track, which means that the train is not moving. Therefore, we have the main switch in this position, and we're gonna consider, to start with, the polarity of the power supply as this one. Okay, plus here, minus here. So in this scenario, what happens is that the electric current flows in this direction. It goes through the switch this way, makes its way to the diode bridge, goes to the red LED powering it up, and then it goes out. The current keeps flowing in this direction, goes to this side, side of the rails here, and comes out over here, closing the circuit. What you notice in this case is that there's no flow of current over here in this section of the rail here, because this one is an open circuit. As you can see, there's nothing closing it because the track section here is separated by these two gaps, and the circuit is an open circuit over here, so there's no voltage, there's no current, therefore the green LED is off, and there's no tension, there's no voltage in this section of the track, therefore the train is not moving. Now let's apply the same let's do the same considerations, but it's always with red LED on and switch in this position. But let's check how things work with the opposite polarity. Okay, so in this case with plus here and minus here. In this case we have that the electric current flows in this direction, powers up this part of the rails, goes all its way through the diode bridge from this input here. This time it powers up it lights up the red LED, and then it keeps going its way in this direction, closing the circuit over here, and through this ramification powering up, like previously, this side of the track. Once again, this circuit is considered open, therefore once again, even if we change the polarity of the power supply, we still have no tension, no voltage over here in this section. The green LED is off, and through the diode bridge, now you understand why I had to put it, we still have the red LED on, even if the current is flowing the opposite direction through the inputs over here. So this is about the red LED and train not moving, and as you can see here, the train is just not moving over this section of the track, but over here there is tension. So for the rest of the circuit the train is moving. Okay, it's just when it moves to this side that things change. Now let's move to the second scenario, where we want the green LED to be on. We want to have tension over here, so we want the train to be able to run throughout the whole loop. In this case then we have to change the position of the switch to this one, and what will happen in this case, now we're gonna is going to be the following. And what we are going to do to start is that we are going to assume that the polarity of the power supply is once again this one with minus here and plus here. What will happen in this case is that the electric current is going to flow in these two directions over here. In this direction is going to power up this side, this section of the rails, and is going in this direction is going to make its way in this direction, and here it's going to give voltage to this section of the rails, and over here is going to go through the diode bridge that is going to power up and light up the green LED, and then it's going to make its way over here closing down the circuit in this direction. Okay, once again in this situation what you have to notice is this, now that this one here is the open circuit now, because the position of the switch has been changed. This becomes now the open circuit, therefore there's no tension into it, and therefore the red LED is off. At the same time the green LED is on, and due to the fact that the circuit is closed now, there's going to be tension over this section of the rail. Therefore there's going to be a difference in potential, because this is connected to the plus while this is connected to the minus, and the train is able to run all the way through without stopping. Okay, let's do the same consideration in this second scenario here, where the polarity is changing. Let's see if everything behaves as expected once again. And what will happen in this case is that the electric current is going to make its way in this direction. It's going to power up this side of the rails, and it's going to make its way over here through the diode bridge from the other input. This time it's going to power up the green LED once again, then it's going to make its way out over here, and at this point is going to go this way to power up once again this section of the rails, and in this direction here is going to close the circuit over here. In this direction, in this other direction is going to power up this other side of the rail. So you can see that this outer section of the rail is powered up with minus, this inner one is powered up with plus, so there is a difference in potential and everything is working properly. There is power here, the light is on here, and everything here is off, as it is an open circuit. Now this is how the circuit behaves, and everything is supposed to be fine, but and here is we're gonna talk about the problem that forced me to introduce the presence of the second switch. There is one problem that I didn't predict when putting down the circuit, and it is the following. If you are switching with the bar from red to green, so let me write it here, from red to green, everything will be working fine, there will be no problem. But there will be a problem when you're going to switch from green to red. Let me explain what I mean. Suppose that you have the train here that is running in this direction, and the lights are, and the green LED is on, so there is power throughout the whole circuit. And let's suppose that at this point you want to change the position of the bar in order to stop the train when it will be here. So you want to take the power off this section of the rail. What will happen is that you can do this and everything will be fine while the train is still on this section, but there will be a point, and the point is going to be this one, where the train, if this is the gap, where the train will be half on this side of the circuit, and with the other half it will be on this side of the circuit. What this means is that the train itself, the train motor, will work as a bridge, and what it will do for the time being here until the whole of it will be on this other side of the track, what will happen is that will allow for a very brief period of time for some current flow from this side of the rail to here, and this will allow through this ramification for a very brief amount of time for the green LED to light. And this is a problem because you will have that for a very brief amount of time both the green and red LED will be on, while what you want is that only the red LED is on and this is off. It's a problem because it affects the quality of your layout, as it affects a lot the visual part of the layout. Things still work properly, but it's a matter of fact that when you want the red light to be on, you don't want this to turn on randomly or sometimes, so it had to be fixed. I've been thinking about different solutions, some involving transistors, some involving pull up or pull down resistors, but after a few attempts, what turned out to be the only reliable solution was to introduce here a second switch, a secondary one, that working with the right synchronization with this one here was going to allow this circuit to be open and at the right time, and therefore in this scenario here where you will have the train to work as a bridge, and therefore having a bit of current flow in this way, it would allow through this switch and for the current not to make its way to the green LED and therefore not power it up. I had this idea while I was thinking about it, and what I was thinking is that I could have easily make it work because I would have had the chance to build a bar somehow that was going to give me the chance to, as you can see here, this is the main, this is the secondary, to act just pushing once to allow the two switches to move back and forward at the same time with the right synchronization, and therefore the whole thing working properly. Okay, so this is it, I will say, guys, for this second video. That is all I wanted to say about it. About this, I'm just gonna go a bit more in details on this third video, the following one. I'm gonna open this up and I'm just gonna give you a bit of information about how to put this thing together, okay, in order to make it work properly. So guys, thanks for the moment, and I'll see you on the third video, okay.